Who's new to NDC London? Just curious. First time? Yeah, quite a few. That's good. This is one of my favorite conferences, NDC, so I'm glad to be back here. My name's Scott Allen. What I wanted to talk to you about were the opinions that I have formed working with a couple different teams building ASP.NET Core applications over the last couple years. So I think most of the opinions that I've formed that I put into this talk are broadly applicable, but of course you can take everything with a grain of salt and figure out what works best for your team. If I were to categorize all these different opinions, I would put them in a few different categories, like how to organize your solutions and projects, how to organize your startup code for ASP.NET Core, some simple rules for controllers, for client code, for C# code, for managing views, and for writing unit tests. So let's get started talking about solutions and projects. Basically, when you start building an application or a system with ASP.NET Core, how should you organize your solution? Where should the projects go? What sort of file system structure should you have? Because one of the interesting things about Microsoft open sourcing so many pieces of .NET Core and other frameworks is not only that you get to see the source code for a particular framework, but we've always been able to do that with a decompiler. We've always been able to get to the source code. What we haven't necessarily always been able to do is look at the bigger picture, look at the project structure, look at how Microsoft lays things out on the file system, how they organize their projects, what they actually check into the source code repository, as well as how they write unit tests. And even the unit tests I've found extremely valuable, because then you can read through the happy day scenarios for the framework and see how it's supposed to work and what's supposed to break. But if you go into every GitHub repository for a .NET Core framework or a .NET Core application, you'll see a lot of consistency in how that repository is structured. At the top level, you'll always find a source folder. So yes, all of the projects will go underneath that source folder. There'll always be a solution file, by the way, in the root of the repository. That makes it really easy for a new developer to walk up and git clone that repository and immediately find a solution file, or sometimes multiple solution files, to click on and open that up and get it running in Visual Studio. You'll typically find a test folder for your unit test, a build folder for build-related scripts and build-related tools. There's usually samples, there's documentation. Sometimes there's also a folder for deployment with deployment scripts and provisioning scripts to set up something in the cloud. So I took that approach also on my ASP.NET Core projects, and I found it very valuable because it just becomes familiar then when you're working in this ecosystem. If I walk up to something that's built in .NET Core, I expect to find a solution file in the root. I expect to see a source folder and a test folder. And I know exactly where to start drilling in if I want to find those unit tests, as well as typically a documentation folder. The one caveat here, those of you that have used Visual Studio to work on ASP.NET Core and have used Visual Studio for a long time, know that that Solution Explorer window that's currently on the slide is showing, it's a lie, right? It's not providing a faithful representation of the actual file system. If I right-click in Solution Explorer and say Create New Folder, it doesn't create a folder on the physical disk. It creates a virtual solution folder, and stuff I put in there can be anywhere in the repository. But Visual Studio 2017, there is this nice feature that not many people know about. In the Solution Explorer window, there's a little toolbar icon you can click on called Solutions and Folders, which switches Solution Explorer into a physical view of the file system. So now what you see is a faithful representation of how you structured your directories and where your projects live, and it's very easy now to right-click and say Add a folder, and that folder actually gets created in the location that you thought it was created. So use the folder view. Also include samples. So if you're building something that is a library, that other people are using your NuGet package to consume that library and are trying to figure out how it works, even if it's for your internal company, it's very useful to be able to go into a sample just to see some sample code on the expected usage of the framework that you've created. And if you look through most of the Microsoft repositories, again, if you're trying to understand some specific pieces of ASP.NET Core or .NET Core, you're trying to find out, for example, how does cookie authentication actually work underneath the hood? What are the different ways I can configure it? If you go into the GitHub ASP.NET Core security repo, there's a ton of samples showing different scenarios for using cookies and using JOT tokens and using OpenID Connect. And those are all very valuable to people that have to consume that NuGet package or those packages and try to put them to work. Questions so far? Is this the content you expected when you walked in this morning? Yes? Okay. At least a few people in the affirmative there. I'm also a big believer in checking in any scripts that might help during development. So for example, if you're using the Entity Framework core and you're a developer who has to always check in some new model code, entity code, and then create a migration and then update the database and so forth, it's nice just to have scripts to do those sort of repetitive tasks that will take some of the guessing and work out of what directory do I go to run this. Because this particular solution, you might not run the .NET executable to create a migration from the web project. Someone might have it set up for a different project that actually is referenced by the web project. So you can check in scripts, even this simple, that says, okay, I want to add a migration, so we're going to change over into the data project. We're going to run EF migrations and add your migration. You just pass in a name. Then we'll do the database update, and then we'll exit out of here. And also, there's another script here. A developer sits down and just wants to start from scratch, start with an entirely new, fresh DB. So a script to just recreate the database from scratch and reseed it with some initial data. Those have been very valuable in development. And the reason this, sorry, to go back for a second, the reason this works so well is that the .NET tooling is so command line oriented. But it's actually quite nice to be able to automate a lot of these processes a lot easier without figuring out how to create a Visual Studio extension or something like that. Also, I'm a big believer in including deployment scripts and templates. So if I'm building an ASP.NET Core application that gets deployed in AWS or an Azure App Service, then I want to have some script or some template as a developer that is checked into source control that I can execute to provision my environment in the cloud. That helps me the first time when I'm trying to get set up and started with the project, but it also includes, and this is just a screenshot of exporting an Azure Resource Manager template out of Azure that describes all the properties that have to get set on an app service. If I'm a web developer who, let's say, is building a ASP.NET Core web application and it communicates over a service bus to some other application, and I know that I'm adding a new feature that's going to require a new service bus queue, or it's going to require a new configuration entry for that app service, then I don't want to be logging into a portal or using a UI to make those changes in the cloud that only work for me, and then remember to document that process so someone else puts them in. You have to think of most of your environments now as programmable data centers. I want to be able to write a script that I check in under source control that someone can diff to see what changes there are. I want to have that in source control and be able to run that to be able to create my environment in the cloud or to update my environment in the cloud and provide a new setting. And those are, I want to say, they're great things to have. Sometimes they're not the easiest things to write. Sometimes it's difficult to encourage developers to stick with this and keep automating every step that they do. But if you have, let's say, a script that goes out and randomly deletes app services that developers have created, a random delete deletes resources, that encourages them to script everything out. So there's a number of different build systems that people are using for ASP.NET Core. Some of us have our own build servers. Some of us use services like AppVeyor and VisualStudio.com. And both of those environments I've worked with, AppVeyor and VisualStudio.com, they're both great. But the one thing I would suggest is both of those services try to provide you a user interface where you can go in and just click some configuration items and say, here's how I want to do my build. The problem I've had with those systems are, first of all, if something goes wrong in the build, it's impossible for me to replicate that locally. So let's say I have an AppVeyor build set up where I just went into AppVeyor and clicked a few things on their web page and says, here's my repository, here's the solution to build, and I'll go build it and do these other steps. When that fails, the only way to debug that or to get it fixed is to log back into that AppVeyor UI and fiddle with it until you get things right, which is very frustrating. But both of these environments, AppVeyor and VisualStudio.com, provide some alternate mechanism for you to do a build. So for example, AppVeyor, instead of going through their UI, if you create a YAML file that you place into the root of the repository for the project that you're building, that YAML file will override anything that someone put into the user interface. And so now you have something, at least in source control, that you can diff, so if something changed, you can kind of see what happened and what's wrong. And you could use this YAML file to kickstart some sort of build script that you've written instead of relying on AppBayer. And hopefully that's a script that you can also run locally for development. So that would be an example of a simple PowerShell script that goes out and does a .NET Restore, .NET Build, .NET Test, and then .NET Packaged, or .NET Publish, or .NET Pack, depending on what you're building. Same thing for VisualStudio.com. They provide this nice drag-and-drop user interface where I can say, let's go out and do a .NET Restore, .NET Build, build a solution, .NET Test, all of this stuff. But when that thing goes wrong, or one of the relative paths that you have configured into there is incorrect, then you have to go around and fiddle with VisualStudio.com to get that working. Instead, what I do with VisualStudio.com is they have sort of a marketplace for these tasks that appear over here on the left-hand side. They have a marketplace where you can go out and grab additional tasks, and there's tasks there for nearly everything, to run Gradle and Grunt and Gulp and so forth. But one of the tasks, or two of the tasks that are in there, are Cake and Pisaki. Anyone use either of those? There's a session coming up on Cake later today after lunch. But Cake is basically a way to define a build for your .NET Core or .NET Framework project using C# code. And it's something that you could run locally to do a build, and something that you could check that into VisualStudioOnline.com and use this Cake task to do your build, the same build online in the cloud. So that's very useful. And again, it's something you can diff and look at and reason about when things change. Let's talk about startup code. For ASP.NET Core, the typical convention is to have a program.cs that contains the entry point for your application, and then there's a startup.cs that, to me, only has 3 responsibilities, or really these days just 2 responsibilities, and that's whatever code you put into the constructor, the code in configure services, and the code in configure. And the reason I say startup.cs should only have 3 responsibilities is because I've seen people put all sorts of odd bits of code inside of here. So ostensibly, to me, these days, configure service, the 2 important pieces are configure services. That's basically where you configure your IOC container. So you say, I have this service with this lifetime, or for this interface, use this concrete type, using this sort of lifetime, transient, or scoped, or singleton, and that's all you put into configure services. For configure, that's ostensibly where you plug in and create your HTTP processing pipeline by adding in middleware. But sometimes when I open up startup.cs, I see people configuring their logger inside of configure. I see people running database migrations or seeding the database inside of configure, and it just gets kind of messy. I'll talk in a second about where I'd prefer to see those sort of startup activities, because yes, you need to configure the logger somewhere. Where do you do it? To me, not inside of startup. To me, the logger would be configured before the configure method. And the reason I say this is because in the ASP.NET Core 1.0 templates, if you did file new application in Visual Studio and go and look in the configure method, there was some logger configuration code that existed inside of the configure method. So a lot of people just ran with that and kept adding more logger configuration code inside of the configure method. The ASP.NET Core 2.0 template gets rid of some of that because that code was hoisted out and put into a default web host builder that gets executed during program.cs, inside of program.cs, inside of your main method. So that's much better. Just make sure you take your logging configuration and specifying your additional configuration sources. Do that if you have to inside of the startup constructor. But these days, I would rather see it in program.cs. The configure services method, there's some projects where I've seen that method grow out of control because people are adding different types of services and adding all sorts of configuration options. And in ASP.NET Core 2.0, you might know that they moved a lot of the authorization and authentication configuration out of middleware and into services. So configure services continued to grow even bigger as people were specifying how to use cookie authentication and how to use OpenID Connect. When I go into configure services, I'd prefer to see something a little bit cleaner like this, just straight one-liners that say we're using this thing, MVC, yes, we're using security, we must be secure, we're using mediator, we're using some data stores. And then each of those methods, if you need to do some additional work, additional configuration options, just write extension methods like add a customized version of MVC. These are the things I need to do. I need to add to the conventions. I need to add some razor options. But by keeping all of that stuff out of configure services, it's much easier for me to go into that method and see exactly what the application is using, or at least get an idea of what method I need to drill into to see what specific options are being set. Otherwise, like I say, I've seen configure services methods that are 200 to 300 lines of code and just very difficult to read through. Same would be go for the configure method, where you are configuring your middleware. Although in here, I believe it is OK to allow some branching with an if-else statement to say, OK, if we're in the development environment, use these three pieces of middleware. We'll use the developer exception page, the database error page, and browser link. I should get that out of the slide. I don't actually. Does anyone use browser link? Yeah. Otherwise, use our production exception handler /home/error. So that would be inside of the configure method of startup.cs. And other than perhaps branching with if-else statements, I don't want to see anything else inside of configure. It's very important to be able to look at that particular part of the application and understand exactly what middleware is installed, under what conditions, and in what order it comes in. Because I want to be able to go in there to see, is this application configured to serve static files? Is this application configured to use MVC with a default route or not? The other thing I suggest is what's interesting about ASP.NET Core is what we are building is an application that I can execute from the command line. Yes, if I'm building an ASP.NET web application, that thing will be fronted by some sort of web server, or it'll have Kestrel running and receive HTTP connections directly. But what I'm building is something that I can execute from the command line, and it's an application that knows everything about its environment. You've already told the .NET Core framework and ASP.NET Core, what are my configuration sources? What services am I going to use? So it's a very useful application that can do more than just respond to HTTP and HTTPS requests. Because if I run this application during the startup, since it knows everything about the environment that it's operating in, that's where I might place some logic to start processing some database commands. So if I need to seed a database or run database migrations or do any of that sort of work to set up my environment, my development environment, this would be a nice place to execute those commands. So you'll notice this is your typical ASP.NET Core. We're going to use a web host builder with Kestrel and a content root and so forth and so forth. But before host.run, there's a process db commands that takes the command line arguments that are passed in and the host, so it knows how to get to things like a service provider. And what we can do with that would look something like this, and hopefully that's kind of visible. And this is sort of just crude brute force code to show you what's happening. So I'm going to look at the command line arguments and see if someone told me to drop the database. Because again, this executable has all the configuration sources, so it knows what database I'm using. OK, I'll go ahead and drop the database, or migrate the database, or seed the database. And maybe you wanted to do one or more of these things and then just stop. In other words, I wanted to not actually launch this application to start processing HTTP requests. I wanted to launch this application because it was properly configured to do all these things, and then I can stop it and start doing my development work. Is that making some sense? Good. Also, another tip, if you ever use services by going directly to the service provider, particularly if you're doing it during startup, make sure you get an instance of iService Scope Factory to resolve the service that you're trying to get to. So what iService Scope Factory will do, when I create a scope, whoops, accidentally clicked there. I'm passing that scope into some other methods, and those methods can say, dear service scope, please give me this DB context, or give me this iLogger implementation, whatever it is. And the service scope factory will make sure to clean things up afterwards. I could just go directly to host.services and do a .get service to try to get to those same things, the logger, DB context, whatever service you're trying to get to. But you just have to be very careful if you do that, because it's very easy to accidentally create a singleton, even if that service was registered to have a transient lifetime. It's very easy to create a singleton that's just going to live for the rest of the process, unless you do this inside of a particular scope. So use that if you're going to try any of these tips that I'm showing you during program.cs or inside of startup.cs, but don't do it inside of startup.cs. And then all those parameters, I can just feed them into a script to a developer. So if they want to do something like recreate the DB, all they do is drop down to the command line, switch in that scripts directory, run recreate DB. It'll go to the website and start it up and tell it to drop the database, migrate the database, seed the database, and stop. And poof, now they have a fresh new database to work with. Project structure. Let's talk about feature folders. Anyone use feature folders? Oh, good. It is very difficult for me, extremely difficult for me these days, to walk up to an ASP.NET MVC project and work with the typical convention of having controllers in this folder, views in this other folder, and then models, somewhere else. I much prefer an organization where I'll have some sort of top-level folder called features that represents the different pieces of my application as viewed perhaps by a business user or someone who's actually navigating that application. So for example, this application has an admin section. Inside of admin section, there's a place to manage a sporting season. And this sort of maps almost to the user interface that I would experience if I was using this application. I go to the admin menu, and somewhere there's a pop-out that says, do you want to manage the season? Yes, click on that. And then inside of that folder, there are controllers, so manage season controller.cs, and views, and perhaps even models, everything related to that feature in one location. Because typically, as a developer, when I go to work on an application, I'm going to work on a feature, like someone wants me to fix a bug in manage season, or someone wants me to implement that. And I don't want to go to 3 or 4 different places to open up all the files that I need to work on that particular feature. I would rather have this one location. And I'm sure you can look at past histories of NDCs. I think other people have done talks specifically about feature folders in the past, but it's the way I like to organize things now. But I caveat that because I'm going to give you one other thing to think about. And this is just an example of how you might take the account controller that gets generated if you do file new project in Visual Studio and ask for the ASP.NET identity features. Anyone who's ever looked at that account controller knows it's a bit of a mess. The last time I looked, what Visual Studio would do is generate 2 controllers, both with about 800 lines of code inside, and they were just very difficult and unwieldy to work with. Breaking that out into features, I might take just the login, logout feature and move that into its own controller, and inside of there, the views and the models associated with that feature. So very easy to find and work with. And I like it so much that I created a NuGet package a couple years ago, so you can just install odecode.add-feature-folders, and inside of configure services, when you're adding MVC, you can just do .add-feature-folders, and yes, there's some configuration options you can pass in there to change the name of the features folder if you want to, for example, but it's just that easy. However, that being said, these days, with ASP.NET Core 2.0, they introduced Razor Pages. Anyone using Razor Pages? Heard of Razor Pages? Yeah, quite a few. I've begun to form the opinion that if I'm building an ASP.NET project that is intended to be a service, so it's primarily there to provide endpoints to communicate over HTTP or HTTPS and serve up JSON or XML, so it's an API project, that's where I use ASP.NET MVC Core controllers. Whoops, we're auto-advancing again. That's where I use controllers. It's like the widget controller over here on the left. And I've begun to like Razor Pages so much that I think they are the best way to go if you're building something that is rendering HTML. So for those of you that haven't seen feature folders, Razor Pages. I just want to do a quick show and tell here. I'm going to create a new project. And you might remember what what ASP.NET identity looked like if you generated an MVC project and you wanted individuals to be able to authenticate and you wanted to store their usernames and password in your database. That's not what I wanted. Let's call it web app 55 and put it in the temp directory. And inside of this next dialog, I'm going to pick not web application model view controller, but web application, and change authentication to use individual user accounts, store the user accounts in my application. And what I want to show you is just a little bit of how Razor Pages can be laid out and what their features are. Because I know a lot of people, when they first heard about Razor Pages, the initial description was something along the lines of, here's something you use when you just need to build that about page and you render HTML. And you don't really need a model or a database access. You're just trying to basically write an HTML page. So in that scenario, you use Razor Pages. But it turns out when I came back and actually looked at them myself, they had a lot more features than just rendering HTML. And they worked a lot like the feature folder approach that I always wanted with models and views and controllers. So over here on the right-hand side, instead of a controller, multiple controllers to manage these users, I have pages for a user to manage their account, to do things like change a password, manage their external logins, set their password. And all these things used to be features that were implemented in those two controllers that Visual Studio would generate. So the first thing I liked about this is now I saw, oh, it must be easier to break things out with Razor Pages, which they could have broken them out with controllers too. But what's nice about this, let's pick change password. So a user wants to change their password. First of all, there's my view. That's the Razor page, change password.cshtml. This is my, let's call it a code behind page, for lack of a better term, that's sitting right there beside it. So everything I need, very close together when I want to work on the change password feature. When I open up the CSHTML, I'll zoom out a little bit. You'll notice an @page directive at the top of the Razor view. That tells ASP.NET Core this is a Razor page. You'll notice I still have a strongly typed model. I can still use view data, render partials. I can still use ASP.NET Core tag helpers. So all the features that you would expect from Razor are still there. And the code behind file, for those of you, a lot of people worried this was like the return of web forms. It's not. There's no view state. The code behind, or the page model, is a class where I can still use constructor injection and method level service injection. So I don't have any hard dependencies, and using HTTP context whatever. I can inject everything I need. I'm not newing anything up. I have these bindable properties, so I know the user is going to enter in their new password. I can have that model binding feature, apply that directly to a property that's on my page model class. And then I can implement methods like, coming down here a little bit, on get and on post. So I know when someone is requesting me to render this form, and I know when someone is posting back with an updated password or new form values. So easier, just as easy as a controller to test and work with, but I think it is a lot nicer for managing HTML and working with forms. So that's my little plug for Razor Pages. If you are working with controllers, here's a couple tips. First of all, when the route attributes first came out, I wasn't a big fan. I said, wow, people will just litter these route attributes all throughout the code, and this is kind of messy. Why can't we just stick with the one conventional route that says, just send /controller/action to some controller action? But what I've discovered is that these routes are particularly useful because it allows people to actually think about URLs instead of always trying to cram everything into that default routing rule that MVC can provide. So they can think about things like, hey, this piece is really in the admin section in the UI, So maybe the URL should map to that, and we should have some sort of admin prefix in front of the URL. The other big difference I've seen is, look through any MVC source code base, and there'll be int ID on 500 different methods inside of that project, right? You look at a method, and you're not exactly sure, well, is that an invoice ID or the employee ID? Is it a foreign key ID? I don't know. But if you encourage people to use these route attributes, they can also name parameters a little better. So this route attribute, sorry about that. I keep accidentally clicking. This route attribute, since I don't have any leading tilde or forward slash, it's going to be relative to whatever route attribute is on the controller. And it's basically saying, I need to see an additional parameter in the URL, which we will call season ID. And so now I have code that has a reasonable name for a variable that I use throughout that method, right? And I really like that better than just having int ID everywhere. Know what I mean? Yeah? OK. Some additional information. I like Mediator. Anyone using Mediator? Pretty sure Jimmy Bogart has given some talks at NDC and has some blog posts. He's the creator of Mediator. I'm a big fan of Mediator because it decouples. First of all, it cleans up the controller. If you tell developers on a project, we're going to use Mediator, and we're not going to cram logic into a controller action, it makes your controller action smaller, which is good. And it also decouples the controller a bit from the end abstractions that are going to handle a particular scenario. So if the user's going to log in, they'll post me some form values that I encapsulate into a login user command model. And I'm going to use Mediator to send that off into some other system that hangs off the Mediator bus in memory that's listening for that particular command to process it. And the controller doesn't have to know who's processing the login user command. It just knows it has to send that message and wait for a result, and the result will tell it if that login was successful or not. Makes things a little bit easier to test. Just a quick tip. I still know people that are building projects, ASP.NET Core projects, where they include API endpoints inside of the same project where they're serving up HTML pages to users. And people can be pretty good about using the anti-forgery token, validate anti-forgery token attribute on controllers that receive form inputs, because we're kind of programmed to do that. But just remember, if you're using cookie authentication, that's where the cross-site request forgery danger is. So if you have API endpoints, you also need to protect those against cross-site forgery. And one way to get the cross-site request forgery token into your JavaScript, so when your JavaScript posts form values to you, one way to do that is to provide an API endpoint that injects the anti-forgery service. And JavaScript can call this get method on the XSRF token controller and use that anti-forgery service to get and store tokens. So that will send a JSON result back that includes the token and the token name that JavaScript should use. And that will also, if it's not already set the CSRF cookie that needs to be present in the browser when a request comes in that validates the anti-forgery token. Embrace security policies. So if you haven't worked with ASP.NET Core 2.0 security policies, they're a really nice way to program authorization rules into your application. So this particular method right here is an example of creating an authorization policy in ASP.NET Core by saying, I want a new policy builder. So that just encapsulates things like what scheme name is being used and instantiates the new authorization policy builder. And then you can do .require claims. So I want to make sure that this user has a claim that says is admin and the value is true. Or I want to require a claim that they're from a specific department. Whatever claims you might get back from your identity provider, you can basically write assertions against them and encapsulate them into a policy, which is really nice because then you can write a custom authorization attribute, user is admin, and use that to decorate your controllers instead of trying to place authorized attributes or doing imperative validation of the user's identity or the user's claims. It's really nice just to be able to sprinkle user is admin on controllers throughout the project and be able to change that policy with, if the claims or something like that ever change without having to change this change what's in the authorized attribute or what's in your imperative code that gets sprinkled throughout. Views. Avoid HTML helpers. I know some people still use ASP.NET Core and are doing it the old way of using HTML helpers like HTML.BeginForm and HTML.TextBox4. Honestly, they were always the worst part of ASP.NET MVC. So replace all of that with the newer tag helpers, ASP-4, ASP-validation summary. So an example up here. It's just so much easier to read and also to author. And you still get IntelliSense help inside of ASP-4, for example, if you strongly type the model for that view. And it's very easy to write custom tag helpers. All you need to do is derive from that tag helper base class, override the process method. So you can create your own tag helpers for interesting scenarios that are specific to your application. I like view components also. So a view component, so where's a view component fit in? In previous versions of ASP.NET MVC, we used to be able to render partial actions as a way you could sort of set up a mini request inside of ASP.NET Core and do a, what was it, HTML dot, not partial, but HTML.action. HTML.action and tell the Razor view engine, hey, go out and call this, go to this controller, invoke this action, and whatever it returns, whatever HTML it produces, take that and place it into my view. So there's a way to sort of build a subcomponent, but it was always a little bit hacky. Those child actions had some difficulties. There were conditions where you could get into infinite loops. It was very easy to do that. View components fix most of those problems. So I can create a view component derived from the view component-based class. I implement a method called invoke, or invoke async if you have to go async. And then that view component gets associated with a view, with a CS.HTML file. So this is just returning a view, but you could also build up a model, return a model. It's all encapsulated. And I might build a component, for example, to encapsulate this bit of markup, which is my main menu. And then it's so easy to use that. Basically what I can do with Visual Studio 2017 and ASP.NET Core 2.0 is just say VC colon and then the name of my view component. And he uses that kebab style where the name of the class might be main menu view component with 2 uppercase M's, but everything here will be lowercase and there will be a dash in front of capital letters that appear later in the name. What about client-side code, managing things like Angular and React? I've become a big fan of Webpack myself. I try to use Webpack to do everything that Webpack can to try to jettison any other tools. I've certainly gotten rid of tools like Bower and some of the other package managers. I just use Webpack in a couple different ways. This would be an example of a Webpack configuration file in a project that's building my vendor.js file. So it's taking all the React modules, React DOM, React Bootstrap, Axios, and ES6 Promise, Polyfill, taking all that stuff and outputting it, bundled up into a file called vendor.js. That would be an example of a simple Webpack config file. But what I have found useful with Webpack is using multiple configuration files and using them for different scenarios. And the one thing to recognize about Webpack is it's not a JSON file that just has configuration information in it. It is a program that gets loaded into Node and gets executed. So if you wanted to do some fancier programming inside of this Webpack configuration file, you can do things like build a list of files by globbing stuff using expressions like this. So I want to go through my features folder, and I'm going to glob up all of the TypeScript files that have .specs in the name because I'm trying to build a bundle that contains all my unit tests, transpile and bundle all that up so I can throw it into my unit test runner. But I need to also, I have these scripts that support that in 2 different places, under the features folder and also under a client folder, which is more of like a shared folder. So that would be an example of some of the programming you could do in a Webpack config file that makes life easier sometimes, instead of trying to figure out things like regular expressions or something down here in module.exports. Anyone use Steve Sanderson's JavaScript services? It's a nice way to encapsulate Webpack operations behind the scenes. So I'll let you try this on your own. Go into Visual Studio, do File, New Project, and pick one of those templates that says, I want to create an Angular or a React application. So one of those last three options. And what you'll have is a project that is set up with Webpack and the framework that you selected, and does a lot of this magic with like configuration files behind the scenes. So typically, all the projects I've worked on where we've used Angular or React, we've had to have another command line window open running Webpack so that every time someone saves a TypeScript file, a new bundle everything gets transpiled, a new bundle gets built, it gets spit out on the disk somewhere. And it's just the pain of setting those things up sometimes. JavaScript Services tries to do all of that for you and tries to do it magically behind the scenes so that I just launch the project from Visual Studio or run it from the command line like I normally would. And in debug mode, one of the things JavaScript Services will do is monitor your TypeScript files or your JavaScript files. So if a developer saves one, it'll coordinate with Webpack to recompile and rebundle all those things, and then just hot patch them into the browser to refresh what you see on the screen, which is really quite nice. It looks kind of like this. JavaScript Services will use Webpack dev middleware when you're in development. And you can turn hot module replacement on or off. So it's a really nice way to integrate some of these advanced, newer, modern JavaScript frameworks with what's happening inside of ASP.NET Core and Visual Studio. And speaking of command line, the built-in Windows command prompt isn't that great. I'm sure many of you already know about conemu or Commander. Those are just free applications that you can download to use instead of using the Windows command window. I use conemu. The nice thing about it, notice it's Git aware. So when I move into a directory, it automatically can detect, hey, this is a Git repository, and this is the branch that you're on, OIDC integration, and it's in red. That tells me that I'm in this folder, and I have uncommitted files. So I may need to do a git commit and a git push to get things working. The other thing I like, you'll notice down here, you can open multiple tabs. So I could have one thing open here with command.exe, another one with PowerShell, another one with a different path, so I can run maybe a Python program, something like that, or open another tab with as administrator if I need to do something administratively. The other nice thing I like about conemu is the split windows. So if I need to run, let's say on the left-hand side here, I need to run Webpack to watch files and transpile them when someone changes things. I want to be able to see that. But I also want to be able to see when my specs change. I want to make sure that the compilation of my spec files is successful. And I also want to be able to see, once everything has been compiled and the unit tests execute, I want to see if that has been successful. And I don't necessarily want to do that by docking 3 windows somewhere on my monitor. I just want one window where if I see red in any of those 3 things, I know something has gone wrong. And the syntax you would use with conemu to start those 3 windows automatically is a little bit quirky, but it would look like this. Basically, start conemu, and in one window do an npm run watch. In another window that has been split horizontally, that's the sh over here, run my test watcher. And then in another console that's split vertically, run my Karma test runner. And if I remember, you would not actually be able to put line breaks in that command. It has to be across a single line for conemu to respect that, but that wouldn't fit on a slide if I didn't put line breaks in. Client code layout, I've become a fan of having a client folder that becomes a location for all of the code that's going to be used perhaps throughout the application. So things like models and services that I rely on, CSS that are specific to that particular framework, like Angular, the CSS files that I might have to know about can go in that client folder. But then some specific things that are specific to a feature. You'll notice over here on the right-hand side, there's a TSX file. So it's a React view written in TypeScript that's actually inside of the feature folder, right alongside a controller and the view that is associated with that feature. And I've, again, found that's a nice way to say, hey, I need to work on this manage invoices screen, wherever that is or whatever that is. Let me just find that folder. I know it's in the admin section. Here's the manage invoices, manage golfers, whatever you need to manage. And inside of there is pretty much all the primary abstractions that I might need to work with. Yes, I might need to change a service over here, but I can deal with that. All of my entry points of where I start looking at that code are here inside of one folder. I'm a big fan of using just NuGet and NPM package managers. So I know Visual Studio over the years has kind of encouraged .NET developers to use Bower. But these days, NPM is quite good with front-end frameworks. So it doesn't matter what I'm doing on the server side with Node.js, if I'm using it to run Webpack or what have you. And I don't care what I'm doing on the client side, if it's just even jQuery is my only dependency, I tend to rely on NPM for all my JavaScript stuff. So I can NPM install jQuery, NPM install Angular, NPM install Webpack. I don't have to worry about Bower or other package managers. Yes, you might select Yarn, but my suggestion is just use one package manager for all of your JavaScript. Don't make a don't differentiate between front-end and back-end JavaScript. I'm a big fan of TypeScript these days. Well, I don't say a big fan. And to be honest, I haven't done a lot of client-side development over the last 12 months. Kind of been on a break from it. But there was a period where TypeScript first came out where I was hoping it would succeed, but I just didn't feel like it would ever work in the JavaScript environment because TypeScript was being developed, and yes, they're trying to be compatible with JavaScript, and yes, every legal JavaScript program was a legal TypeScript program, but it just didn't fit in the ecosystem. It felt like every time I tried to use TypeScript, even with, say, like jQuery, there's all these weird hoops I had to jump through and install these typing files and so forth. But in 2016, it really became remarkable, I thought, the way that TypeScript team started working with the Angular team and actually just became so integrated with the JavaScript ecosystem that it became so much easier to use. And some of the features that they added to TypeScript made it so much easier to use. And I'm not talking about runtime or syntax features. I'm talking about features like the module resolution feature. So I want TypeScript to work just like Node does. If I have a Node modules folder and I tell TypeScript to import something, it should go off and use the same module resolution algorithm as Node.js and go searching through the directories inside of Node modules to find that. The ability to describe to it the libraries and the features that I have by default. So don't warn me if I'm using promises. I guarantee you I have a library that will polyfill or shim ES 2015 promises if need be. And the ability to describe paths on where to find modules. One of my biggest frustrations developing JavaScript, like in 2015, trying to use all these different tools, was just trying to tell the tools where things belong, like what folders to look in. So don't look just inside of my Node modules folders. If I import some service into a TypeScript file, that might be a service that I wrote custom. So where should you look for that? Look inside my client/script folder and start using your Node modules module resolution algorithm on my folders also to find the files and things that I'm using. So TypeScript's come a long way and works pretty well. I still prefer using Visual Studio Code, so the one team I work with, we always have the solution open two ways. It's open in Visual Studio, that's where we do all our C# work, and we have Visual Studio Code pointed to the same root folder, and that's where we do all of our TypeScript or JavaScript or ECMAScript work, just because the editor seems to be a little bit faster and the IntelliSense is a little bit better. And you don't get as many false positives for errors inside of Visual Studio Code. And I think of www root as my bin folder for the JavaScript application. So that's where Webpack will bundle everything and place it. There's nothing really that I own inside of www root. Not many people know this, but you could install the ASP.NET Core static files middleware multiple times, pointing it to different locations. So my thought is pick a folder that's going to be served by static files middleware in ASP.NET Core that's going to be your client-side bin folder. That's where you produce all your compiled or transpiled output from tools like Webpack. And then if you also have additional static content, the images that you need to serve and so forth, you could place them in a different location, a different folder, and also create another instance of static files middleware to pull assets from that folder. Some thoughts on testing. I have no problem using a single test project across multiple projects. I've worked with teams where every project that you create, every CS proj, had to have a corresponding .test.cs proj file, and that was okay, but sometimes it became hard to find things and just felt a little bit, I don't know, unnecessary. To me, what is a project? When do I create a new project? I'm creating a new project because I have some deployment requirement. That piece of code has to be deployed differently than this piece of code over here in a different project. When it comes to test code, all I care about is that it all gets compiled and it all gets executed by a test runner. I don't have to deploy them in different places. I don't have to share them differently. So just placing all the test code inside of a single project seems to be a little less overhead inside of tools like Visual Studio. And then everyone's using XUnit these days, so I don't really, that's not a very opinion that gets a lot of pushback, but I know some teams are still trying to use MS Test, but XUnit's the way to go. I personally try to avoid mocks, and my actual take on it right now, this bottom piece right here, to be a successful mockist, you must dislike mocks. So do I use mocks? Yes, I use mocks, but I try not to. I dislike them. So I've been trying test-driven development since 2004, and I've tried mocking, and I've tried to avoid mocking, and just the problem with mocking that I see a lot of people fall into, the troubles, are that they do too much interaction-based testing, and it's still possible to ship an application into QA or into production that fails because with all the unit tests pass. Because people were testing interactions, not trying to do state-based testing, not trying to think about the tests in a way that would actually faithfully test, is the system meeting the expected requirements? So kind of along those lines, I'm a big fan of the ASP.NET Core test host. So there's a NuGet package out there, Microsoft.ASP.NET Core.test host. If you look through the ASP.NET Core repositories, you'll see this is used in a number of their test projects. And this is just a little example of what you can do with it. So what is it? You could think of it like an in-memory server. I'm going to create a server, so this method wraps the creation of Microsoft.ASP.NET Core.test host. But what it has the ability to do is create a host that I can talk to. That host uses the middleware that I've configured inside of startup.cs. It uses my configuration. It knows it's going to work just like my application does when I send it an HTTP message. So I'm going to create an instance of that server, and I'm going to send off a GET request that would look like it's going to example.com/protected query string x requested with blah, 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 blah. And I'm going to start writing asserts about what that server returns to me, because I'm hoping that the cookie authentication options were configured properly for me so that it sends me a redirect response to go to example.com/login. Right. So and here would be another example test, a little bit simpler maybe. I'm going to create a server, send off a GET request to example.com/normal, and make sure I didn't get blocked. Make sure I got back a status code of OK. So it's a really nice way to do integration testing and see if your application's working end-to-end. And to me, these days, I'm a big believer in getting the most bang for the buck out of test code. So the less test code I can write, the better, because things are going to change, and it's always troubles me when I have to refactor test code. But if you think about this, ASP.NET Core test host, running your application, which you're probably using something like the Entity Framework, maybe, to talk to the database. Well, there's also an Entity Framework Core in-memory provider that I can get instantiated when I'm running this test host. And now all of my operations can flow through my system from the very beginning, through the middleware, into a controller, into the database, and everything just stays in memory. Nothing goes over the network. Nothing gets written to disk. So EF Core in-memory provider. I can use it just like Entity Framework Core talking to SQL Server, with a caveat that the EF Core in-memory provider doesn't apply all of the constraints that the real SQL Server provider would provide. So I don't remember all the scenarios, but if you try to insert a record or insert an object that references another object, where in SQL Server it might throw a foreign key violation, the in-memory provider won't do that. So yes, you'll be able to get away with some things. Your test might miss some things. But if you can run a request through the ASP.NET Core test host that goes all the way down and interacts with the in-memory database, that gives me, with just a little bit of code, a high level of confidence that this would actually work when it gets shipped into production. And I'll make these slides available. This is just an example of configuring that in-memory instance, and the important part is this line that my mouse is over, use in-memory database. But the combination of those two things, I have found that I've been writing more integration tests, what people would call integration tests, and maybe fewer unit tests, and trying to mock things out. Because if I want to test that my application, let's say, fails if I try to insert duplicate season names where season is some sort of sporting season. This one's not using the ASP.NET Core test host, but I can instantiate a controller, inject my mediator, create the command, the mediator command that's going to go into that controller. Go to my in-memory EF context, tell it to go ahead and insert an existing season, and now tell my controller to create this thing. User just made a request to create something with the same name. I should get an error back out in model state. So did I isolate the controller from the services it uses? No. So is it a true unit test? No. Is it a decent integration test? I think so. I get a lot of value out of those, 10 lines of code. For C# code, so the biggest thing about C# code with ASP.NET Core, I know a lot of people find the ability to run ASP.NET Core on Linux very compelling, because Linux is obviously generally a cheaper environment in the cloud. So I see people trying to write and develop ASP.NET Core projects inside of Visual Studio on Windows, and then trying to deploy it on Linux. And a couple things that always come up are things like, hey, I used \n instead of using environment.newline. So if you use environment.newline instead of trying to hard code characters into strings, you will get the proper newline string defined for the environment that you're operating in. Same thing with combining paths together. Is it a / or a \? If I just use the path.combine method, that'll combine two strings into a path in a way that works on whatever operating system I'm targeting. The other suggestion would be really, if we're going to create ASP.NET Core projects on Windows and deploy them on Linux, then consider running Docker, because that's one of the things it's really good at. I'm going to work on Windows, and Visual Studio is going to be running in Windows, but my ASP.NET Core application will really be running in a container on a Linux VM, and I'll find out about these issues a lot quicker, environmental issues. Same thing for environment variables. Environment variables can have different names on different systems. So what is home on one type of system might be user profile on another. And just a personal thing, I'm not a big fan of the async suffix, so I tend to not write something with the async suffix on methods, even though it's an async method. And it comes from Bjorn Strustrup, who said one day in a lecture or an article, when there's new features in a language, people insist on loud, explicit syntax. So when async await first came out, I think we wanted this loud, explicit syntax in our C# code so that we really were sure that this was an async method. Right? It would have the async keyword and then the async in the name. But these days, when everything's going async, for an established feature, I just want the terse notation. I don't want to type async at the end of every method. So to me, sign out tenant user, that might fail some code reviews in certain places, might get picked up with certain tools with a warning that says, hey, you have an async method without an async suffix. I say that's OK. And that concludes this part of the presentation. So I do want to thank you for coming out. Any questions? I'll take that as a no. I'll be up here because I'm in this room for the next session. So thank you for coming out.